A very good morning to all my 10th class students. Children, as you know that we have been learning chapter 4, that is carbon and its compounds, and today let us just wind this chapter off. As you know that most of the chapter syllabus has been deleted for you, and there are only two small topics left in this chapter. Let's wind it up today. Okay? So we have been learning about carbon and its compounds. We learned how versatile this compound is, this element is, and what makes it so versatile. The reasons also we have seen, and also we have seen how it forms covalent bonds. Right, children? Today we'll learn about hydrocarbons, children. So as you know, the name itself indicates hydrocarbons are those compounds which contain only hydrogen and carbon. So those compounds which contain only two elements, they are called as hydrocarbons. We have seen that carbon forms aliphatic chains. Aliphatic means here straight chains or branched chains. Anything that are not cyclic, they are called as aliphatic. They can be branched, they can be straight chains. And carbon also forms cyclic compounds also. So based on this, hydrocarbons can be basically classified into aliphatic chains, compounds which are arranged, in which the carbon atoms are arranged only in the form of straight chains or branch chains, and those compounds which have cyclic structure. So hydrocarbons, basically we have got two kinds, major classifications of hydrocarbons. One is this based on the arrangement of carbon atoms, and the other one based on the bonds that are present between the carbon atoms. As you can see here, we know that carbon forms covalent bonds, and we know covalent bonds is of actually three types: single bond, double bond and triple bond. So the carbon-carbon, the backbone, may contain some double bond and triple bond. If there are only single bonds present, then we call them those compounds as saturated hydrocarbons. And you know, alkanes are the group of compounds which come under this. And if the carbon-carbon backbone contains a double bond or a triple bond, then we call them as unsaturated compounds, and alkenes and alkynes are the names given to those, general names given to those compounds which have an unsaturation. That means which have a double bond or a triple bond in their structure. Okay. So hope you understood. Hydrocarbons means it's a group of compounds which contain only hydrogen and only carbon. Hydrogen and carbon, that's all. Can you tell me what is the major source of hydrocarbon? It is nothing but crude oil that is extracted, children. Nothing but petroleum. So we know that how petroleum is formed. We have learnt in our lower classes how petroleum is formed. And most of that dark viscous liquid crude oil that we get from underground reserves, they contain hydrocarbons, children. So if it is asked in the examination which is the largest or biggest source of hydrocarbons, it is definitely the crude oil that we get from underground reserves. Now, in order to understand one more topic of your syllabus, that is homologous series, we need to understand first of all the nomenclature, how names are given to these hydrocarbons. So if you see, I told you that alkanes are the saturated hydrocarbons, alkenes is the unsaturated ones, and alkynes are these contain double bond and these contain triple bond. This contains single bond. As you can see, ALK is common. Only the suffix, okay, anes, enes and ines, this is different. So if any name ends with this suffix, ANE suffix for example, that means it shows that it is a saturated hydrocarbon. Suffix I'm talking about. It's a general name given for that group of compounds. Alkanes. So the suffix is ANES. It means that it contains single bonds only. If the suffix is ENES, then we can say that those compounds contain carbon-carbon double bonds only. Some places only double bonds can be present along with the single bonds. It doesn't mean that the whole compound has double bonds. Somewhere in this long chain, somewhere between any two carbon atoms, if you have a double bond, it is considered as unsaturated compound only. So such compounds can be given the suffix ENES, that is enes. And then if it contains anywhere between any two compounds a triple bond, not a double bond but a triple bond, then such compounds can be given the name, the suffix YNES, that is ions. Now that is about the suffix. But what prefix would you add? This is just a general term I said. Now particularly a compound, how is it named? So the nomenclature of hydrocarbons basically depends on how many carbons are there in its backbone. So if there are only one carbon, if there is only one carbon in the structure, then that compound will be given a prefix now. A prefix is meth and a suffix will be, because it contains only only one carbon, no question of bonds at all, because bond will be formed between any two carbons, right? Because it has only one carbon, there is no bond. Naturally, it is, what is it? It is an ane, nothing but alkane. So this is the prefix, and if it contains a single bond only, the suffix will be ane, the prefix will be meth, and you combine these two, the compound name is now methane. Did you get that, children? What is a methane now? It is a saturated hydrocarbon. How can I say that? By looking at the suffix, okay? Ane. Suffix is ane, that means it's a saturated. Meth means it contains only one carbon. Got? Now, if the compound contains two carbon atoms, the prefix now will be named as eth. Eth. Okay, the prefix is eth, and between these two carbon atoms, how many carbon atoms are there? Two carbon atoms. Between these two, if there is a single bond present, what suffix should I take now? Ane. If it's a saturated one, ane. So add prefix is eth and suffix is ane. What is the compound's name now? Ethane. If not a double bond, if there is if not a single bond, if there is a double bond between two carbons, the prefix remains same, because the prefix indicates number of carbon atoms. It will be the prefix, and because it's double bond present between two carbon atoms, the suffix would be ene. So what is the name of this compound now? It is ethene. Got it? Now, can you guess what would be the name for C triple bond C? It is eth again, because two carbon atoms, and ine. It is ethyne. So that's how the nomenclature of hydrocarbons is done. If it contains three, the prefix is prop. That means propane, propene or propine. 4, butane, butene or butine. In that way, we have n number of carbon atoms. As I told you, when I explained you about the versatility of the carbon, I told you that it can form very, very long chain backbones, and depending on that, the nomenclature is done. It can be n number of carbon atom attached to each other. So this contain, it doesn't mean, please, one more thing you have to understand here. Only CC, if I write like this is not the complete structure of ethene, because it contains hydrocarbons. I have drawn only carbons. You have to arrange hydrogens to it based on the valency of carbon. Say for example, if it is one carbon, methane will take methane. We know that the valency of carbon is 4, and it is indicated like this. To each bond, you have to put one hydrogen. So what will be the structure of methane? It is CH4. If it is ethane for example, 2 carbon atoms attached by a single bond, and here one valency is satisfied, and there will be 3 more. And for all these 3, you have to put one hydrogen. So how many hydrogens altogether? How many carbons first of all? 2 carbons, and to each one 3 hydrogens. So it is C2H6. If you see this carbon, you have 4 bonds. 1 bond with carbon, 3 bonds with hydrogen. The same thing is with the second carbon too. 3 bonds with the hydrogen and 1 bond with the carbon. In that way, when you are asked to draw the structures of carbon, first of all you have to draw the backbone, carbon backbone, and then satisfy the valency and put the hydrogens. When you do that, the general formula becomes this. See here children, the general formula for alkanes is CnH2n plus 2. That means, let us see, Cn means number of carbon atoms. If number of carbon atoms is 2, for example, Cn H2n plus 2. C is 2. H will be 2 into 2. That is 4 plus 2. That is 6. C2H6. That's what we got here. Right? So that is the general formula for alkanes. For alkenes, it would be CnH2n. That means if C is 2, H would be simply 2 into 2. That is 4. So this will be the general formula for ethane. Now the question for all of you is, why is the general formula different for all these, and why the extra two hydrogens are present only in alkenes and why not in alkenes? And here you can see 2 and minus 2. Did you understand why is there a difference? Please, it's very simple, very if you know the logic behind it, it's very simple. Please try and answer it. Okay, what is that? Why are the general formulae of these three different? Here it is C2. If it is 2 carbon, it is C2H6. If it is ethane, it is C2H4 only. And if it is ethyne, it is C2H2 only. So why is there a difference? Please try and find out. And homologous series is the last topic that I have to deal here. It might be asked in the examination too. So what is homologous series? The last concept here. When you take a particular group of hydrocarbons, if you see this methane, propane and all that, then all the members of the group have same physical and chemical properties. The members of the group have same physical and chemical properties, and they differ by a CH2 group only. All the members of the group, particular group, if you take alkanes, all the members of the alkanes contain carbon and hydrogen only, and they have got like similar chemical and physical properties. The length is only the difference here. More number of carbon atoms. So when you take a particular group, all the members have same physical and chemical properties, and the successive members differ only by a CH2 group. Like I'll explain you with an example. What is the formula of methane, children? CH4. What is the formula of ethane? C2H6. Can you tell me the formula of propane now? Cn, C3, H2n plus 2. That is 2 into 3, 6 plus 2, 8. C3H8. Now, just to see the difference, find out the difference between two successive compounds. It is CH4, C2H6. Let's just subtract now. C2H6 and CH4. You subtract this 2 minus 1. Nothing is written, means it is 1. That is only 1C. 6 minus 4. That is 6 minus 4. It is 2. CH2. What is the difference that we got here? 2. CH2 we got. So now let's see the second and third. You subtract these two now. C3H8 and C2H6. Can you find the difference? C1 and H2. So if you see, all these contain all these successive compounds, they differ only by a CH2 group. So such a series, such a group where we have compounds which have similar physical and chemical properties, and the successive compounds differ only by a CH2 group, we call such groups as homologous series. Got it? So here comes the end of our fourth chapter, carbon and its compounds. I have already sent you the notes for it. Please prepare well for the PF2. Okay. After the PF2, we'll be starting a new chapter. That is the last chapter in our chemistry, the periodic classification of elements. Okay. If you have got any doubts, please ask me personally. Thank you.